Okay, so we're going to go over an Earthworks project. This is a full-size dam in Australia, Clunes, Australia, 4-meter wall, upper swale and lower spillway swale going to another water source that we'll see later. So basically the little person is standing way out in the landscape. We're looking down the hillside. That's at the key point, or the intersection between the concave and convex slope of this. So they're standing in the landscape. They've located this key point where they want to put the dam wall. Okay, so then they're going to lay out where that dam will be. So there's a slight valley and the dam wall. You can look on a contour map. This contour map is detailed but old and not easy to see. So it can give us an indication where about there would be a dam. There could be a dam there, but we're going to have to go outside and actually walk the landscape to find that key point. So once they've done that, the person standing there, they said, okay, this is about where I can identify, I think there's going to be a dam. So they're going in and they're taking a bulldozer, and they also have an excavator for this particular project, and they're clearing away the topsoil. The topsoil takes about 1 inch takes 1,000 years to create of topsoil. So you imagine you go to a site that has 3 to 6 inches of topsoil. That's a lot of time to create that. We want to stockpile that for use at the end of the project. So we're going to push that to stockpiles around the building site. So this is on the outside edges of the site. So that's what they're doing right now, just clearing away the topsoil down to the subsoil. The bulldozer is better at that job, but the excavator is there, something to do, so he's scraping. The bulldozer will then come and push it, okay? So they're just working as best they can. We start to see the area, the divot in the landscape where the dam is going to be on the backside, and then if we build a dam, it will back flood up this valley, at this upper part. So top soil piles start to be accumulated around the, say, work area. And then they start to dig the keyway. So the keyway is the trench that's under the dam. So when the dam is like this, there's a keyway that sits in and locks the dam into the hillside. So when the water pressure is pushing on the dam, it doesn't slide down the hillside. So this keyway, because it's a very large dam, is the width of the bulldozer and about the height of the bulldozer, okay? So say something like 8 foot by 8 foot square in a curve that's going to lock the dam into the hillside so it doesn't slide. So the dam excavation is happening. The bulldozer is pushing, and it has a ripper. So the ripper basically is dragging and pushing and running the ripper, and then the excavator is pulling up and throwing out the thing. So here we go. Bulldozer rips and pushes. The excavator pulls and throws out. So there we go. Side. You see the rippers on the back. So it's hydraulic. So what he does is when he's driving forward, he drops it, he rips it, he backs up, then he can push the ripped portion. Excavator throws it out. So the bulldozer rips the bottom of the dam trench, then pushes the material to the end of the trench. The excavator digs it out and piles it up on the downhill side to start creating the backside of what would be the dam to be used to build the back of the wall. So now the dam trench is cut, and they actually start to get to groundwater. So if they go any further, it doesn't really do anything. That's the actual groundwater level. So this is an instance that we don't know the compaction of the soil, and the weight of the soil is not as compacted as the machinery. The machinery weighs more than the soil. So when we put the dirt back in and we run the tracks over it, we'll actually compress the clay more than it would have been compressed naturally. So this is going to make that homogeneous mass that where the keyway comes up, and it'll lock into the dam because it's over compressed. So they're going to do that in lifts. They're going to put in soil, good clay, and then compress maybe about 8 inches max, and then run the machine over and smush it. And in that instance, the weight of the machine, so most excavators, backhoes, track hoes, they're actually rated in the weight. So if you have like a PC 200, it weighs 20 tons. If I have a PC 300, it weighs 30 tons. A PC 100 is 10 tons, okay? So then that way the civil engineer knows the weight of the machine and the track width, and he can calculate the compression, okay? So at this point, they're restockpiling the dirt. Got it all ready. They're going to put it back into the trench that they dug, because remember, when they compress it, it's more compressed than the trench itself. 8 inch and compact, 8 inch and compact, 8 inch and compact, and build it all the way back up. So now they have a big block that's super compacted. It's like concrete compacted, okay? And then when they put 8 inches on top, that'll all go around, and they'll have the dam fully compacted, locked into the hillside, and the water will not be able to slide it down the hillside. So partially filled trench, compaction is the most important part of dam building to make sure that they keep running the equipment on top and compacting it. The trench must be cut through underground water flow and be packed with the best clay you have available on your site. So if you got into an area where this part of the thing had really good clay, but this was kind of silty, then I would not use the silt till later and then use the best clay I can. So packing the trench with compacted clay, and then we take the larger machine. He's going to track on it to make sure it's really well compacted, the excavator. The excavator packs from side to side, and at that point, while he's running and driving over it, the bulldozer will go and start to push dirt up for the next lifts. So the clay's piling up, and they got another section. Now they can start to build the wall up more, another, say, 8 feet. So beginning to build the wall, they're now in the, if we had the hillside coming this way, they start to track in and push up and dig out. So they're digging out and pushing up, and that's going to make the backfilled portion that we'll see. So both machines work as a team, and they're pushing the material and they're track rolling the wall. So as he digs, he rips, he pushes, and then when it goes up, he's rolling up the wall, and then he drops the dirt on top. The excavator, we're going to see, is going to drive on top and smush down. So he's pushing in, smushing down, creating that wall. So the excavator strips out clay. Sometimes the excavator needs to get in. Maybe the clay at the bottom is too tough or has rocks. As we go down, it's more compacted. He'll go in and rake it, if you will, and then the bulldozer can push it. So the bulldozer is pushing it up the wall. He's tracking. So as he's pushing up, he's pushing into the wall, which is compacting it. The excavator's on top, rolling, smashing it down, and you can see the dirt falling. Roll it, push it. They just basically keep repeating that along the arc. So now we start to see a dam wall forming. So that's down the valley, and we have a nice big curvature where the bulldozer's cutting, tracking up, depositing, and they're rolling. Team. So the wall height keeps increasing until this 3.6 to 4 meters maximum. Okay, and the bulldozer finally levels the top. Okay, he has a nice blade on a bulldozer blade. It can go up, down, left, right, like this, or any of the things. So in this instance, he's just got it set level, and he's cutting it level. They're going to track roll it in. A car at this width would be able to drive on top of the dam. The height of the dam, remember, is 1 meter taller than the spillway. So at this point, they're going to use a swale to cut a swale, right, out, and they're also going to use a swale to capture water. So if I'm the dam, and I want to get water to my dam, I throw my arm out on the hill, right? The water runs down the hill, hits my arm, and then comes into the dam. But if I fill up, right, I put a lower arm. This lets the water out, controls the height, and then that water, if it floods, goes to another dam. In, out, down the landscape. So the topsoil is spread back around the dam. So it took a long time to create. It's highly, we want to repair the landscape, if you will. So the grass, you can see, is still inside the soil. It's going to regrow. So at this point, we want to put it in, but we don't put it into the bottom of the dam. We only put it to the water level. So the height of the water, we don't put it into the water, okay? You put it in, it won't do anything. It'll become static and basically die. The microbial activity would die anyway, so it's a waste to, say, put it into the water. So we just put it down to the edge of where the spillway would be, 1 meter. So here we go, top wall is dressed. You can see that almost all the work, 99.5% of all the work that's performed is performed with people inside of the equipment. It's not very much physical like labor. But right at the end, people are going to come, you kind of top dress it to make sure there's any lumps, or with a hoe, make it nice and pretty for your client. So topsoil is evenly spread down to the water line, very nice. Finishing, topsoil dressings, all quite nice. A little bit fell in, no big deal. We go in, just make sure it's nice and flat. So when the rains come, it'll compact down, the grass will regrow. If you want to add any more grass seed or ground cover seeds or anything like that, you can broadcast that, no problem. So at this point, we want to get onto the swales. We have a pond, but it would only fill up by water falling into the pond. That might take a long time if the only water that enters the pond is what falls by rain. But if we throw out a big arm, we can catch all the rainfall that falls on the hillside. That would have been overland moving down the hillside. It's quite steep, right? So if that water was going down the hillside, one, it's leaving the property, and two, it could create erosion. So when I make the speed bump, the water hits the bump, right? It's level, it back floods, and then if here's opening, it drains into the dam. So building the spillway is called a level mound or a non-compacted. So when we make the earthen mound for the swale, we do not compact it. Okay, they don't drive the equipment on it. So how do they do that? They have the bulldozer. The angle of the slope is like this, and if I put the bulldozer and it drives like a car, it wouldn't be able to. It would just be flat like this, right? So what they do is they put the tracks on it, and then he levels his blade. Right? So the blade, if he was like this, and then he moves the blade. Yep. So then he cuts the top edge, and then he moves it down like this, and he pushes it like this. So when he cuts this edge, it moves the dirt and deposits it on the downhill side. And then he cuts a little bit, then he drives, and he cuts a little bit until it cuts flat, and it's moved the dirt. So that's what he's doing right now. His blade is tilted, and then he's cutting here, depositing here, which is called side casting. I'm side casting the dirt due to the articulation of the blade. So at this point, they've side casted, cut a level. In Australia, labor is very expensive. It may cost up to $30 to get someone to help you. So if you're doing consulting, that's going to be something you want to think about. So at this point, they have a laser. That means that you only need one person, not two. And the thing's okay. And equally, now you can hook the laser to the bulldozer, and actually even to the computer controls of the bulldozer, and the laser will move the blade. Okay. On this job, it's not a big job. Don't have that kind of money, but this works. So it's pretty accurate, but it could be more accurate. So the final cut has been made. The operator watching the person walking with the level. So there we go, checking the exact level with a laser level. The spillway is designed to discharge surplus water. So any surplus water, meaning extra water running down the hillside, goes into that and goes in. So it's crucial for the dam to function without breaking over the wall. So if the water went too high, there's no way for it to get out. It would go over the top of the wall, cascade down, and erode away the dam. So in this instance, this is called a silt trap pond, or excavated on one side. So what happens here is, now that I have this level spillway, I want this to actually flood before it goes into the dam. So I'm going to make like a little mini dam here. So before it goes into me, it has to come up, say 30 centimeters. So the water comes into here, soaks in, but after 3 rains, it can't soak in anymore. It's saturated. It starts to flood. Then it has to get up to the little mini dam to flood over the mini dam, into the pond. So that's what we're going to see is happening here. That's called a silt trap, okay? So at this point, they start to rip the bottom swale, which is the exit, right? So we have a top swale bringing water in, and a bottom swale bringing water out. So there's the pushing the dirt, ripping the bottom swale. They're shaping it, and it looks nice, but a big rain came before it was done. So you can see the amount of water that would have gone over the hillside and hit this, not perfectly finished yet, but speed bump, right? One thing to look at this is you see the water is perfectly flat. There's no ripples. That means it's sitting on the hillside level. It's not going anywhere, because at the other end, there's the little mini dam, right? So it's soaking in, and at this point, though it's sitting on the hillside, none of the water is going into the pond or dam. So you see it sitting on the top, but it's not spilling over. It hasn't saturated yet. Once it gets saturation, after maybe 2 or 3 rains, then it will start to fill the dam. So here we go. Input is obviously marked by the spillway. So at this point, it's rained like 2 or 3 more times. The ground is saturated. The water has now flooded, and it's starting to spill over and fill the dam. Okay. So there we go. Water running in from the spillway, cascading down. At this point, you have to be really careful. If it does it too much, or it's really big rainfall events, it may cut my little earth dam that I made. Yeah, and then if it starts to cut that, it could erode. I have to come back and fix it, like put back the berm. Yeah, after a while, that'll get settled in, and it should. And then once the water gets high enough, it doesn't matter because the water is up to that berm, so it won't break. So at the beginning, be careful. This job's really big, and you know that you're talking about almost 2 kilometers of swales. It'd be very difficult to get enough people, and where this job is, there's not people available to do like what we might see in Jeff Lawton's videos, where he has a team of 20 woofers, and they've prepared all their sheet mulch and all those things, and they go out there and they basically permablitz, or 20 people working for 3 days to do the swale, right? So if you can get the people available, that's nice. But in some instances, especially on a broad scale, larger landscapes, way in the outback, that's not possible. So they have companies like this, which is called hydromulching. Hydromulching is basically they take a concrete grout machine that they would normally spray concrete into a swimming pool, right? So you put it in, it sprays it. Instead of spraying that, they put in newspaper, yeah, and then they put in organic glue, which would be like tapioca. So if we took like a tapioca starch or potato starch and mixed up what we would know as Elmer's glue, like for kids glue, and you mix that in with the newspaper, they put in a food coloring because it looks nicer than spraying gray everywhere, so they spray green. And then they put in all the seeds, whatever you want, whatever type of seed you would like to do, your ground covers, your tree seeds, right? You put in there, mixes all together, and then they spray it over the exposed soil. So we're going to see that. So they're spraying that over this exposed soil. They call it spraying on paper pulp seed and an organic glue. So this is certified organic, and it's a way to get the seeds. If you just go broadcast the seeds, the birds will come in and eat them all. But when the seed's mixed up into the paper, it sticks on, and if it rains, it doesn't wash away. So then the seed comes, the paper rots into the soil as a mulch, and then you eventually get your growth. So hydro-covered mulch, just sprayed on organic, a newspaper mixed with starch. So cool, spraying it. You can see the owner's home in the background. And this is called a versatile rough country spray ute. So you have to know your nomenclature if you're going to work in Australia. If you call it a pickup truck, they'll make fun of you. So they sprayed the cover crops and the legume trees. It took 1 day to spray all of this and seed it. Okay, 2 people 1 day. The owner wanted to have on this particular swale pioneer rainforest trees. So later it's not going to be horticulture. It doesn't have fruit trees. It has long-term rainforest trees for local bird populations. So they did 3,500 metered squared in 1 day of cover seeded for trees and mulch ground covers. After 1 month of raining at the property, you can see the ground covers, and they also were a lot of mixtures of wildflowers. So you have your legumish ground covers mixed with wildflowers, and then we'll see that the legume trees will start to come up, and then finally the long-term trees or rainforest trees. So silt trap ponds are working. They're holding they're holding the water into the swale. So when we have the erosionary event, the erosion's coming down the hillside because it's very steep, lots of rain in this location, picking up silt. The silt goes into the swale. Over time, the swale will accumulate the silt because when the water stops, the silt settle. So you can actually go clean the bottom of your swale and you get really great soil that you can put in your gardens. So we do that here in Raktamachat. I clean we have a 3-year rotation because we have 3 mainstay swales. So I clean 1 swale per year and then let them accumulate silts and organic matter. They flood in our rainy season, so we get like crabs and little fish and things that do their thing inside the water. So you get a lot of nutrients. That's really some of the best stuff that we can put on our garden. So it's a great deal. So there's your finished job. The swales are full, so it's been a good rainy season. The swales are holding water in the landscape, showing that the hillside is at full saturation, right? The pond is full. Any overflow is coming down and going to other irrigation, or what we call total irrigation. So this particular property, the owner has done lots of earthworking to have water catchment on. And then each one of the swales later, if you were to look 5-10 years, you wouldn't necessarily see the view because they become windbreaks with pioneer rainforest trees. So 8 inches of rain falls in 1 night and the dam is full, okay? Wow, really nice job. So there you go. But 8 inches of rain is a tremendous rainfall event. The swales are earthen, remember, and they're not compacted. So at this particular point, there was a bend and the laser level of something didn't go exactly right. So there was a little dip. So the water got a little too deep and broke the swale. And then the water for the full swale is 30 centimeters deep. All that water ran down and hit the next swale and broke it, okay? Cascaded down the hillside. So at that point, I had to call back the equipment to come and push back up the dirt to fix that swale. You can see there that little dip where it's holding water. That's probably what affected that. And so sometimes that happens and you have to make a repair. So he fixes it, going and fixing all of that, right? And so here we can see the picture where this is the back side of our dam. and the dam is full, and we're still getting some seepage out the back. And that's why it's very, very important that we had the right angle. So if you have this seepage event at the beginning of your dam before it solidifies, right? Because over time, the weight of the water will compress the soil. If it rains on that and you have the seepage and it's too steep, you'll start to get erosion and you could lose your dam. So that's why we want to have that nice, like say, 30-degree angle, okay? So that over time will stop, the grass will grow, and you shouldn't have any problems, okay? So yeah, upper swale, lower swale to the dam, very nice. You can see the cut into the hillside, so we've cut down, pushed over, created the berm. The water will run down that hillside, which is at like almost a 40-degree angle. So when it rains, quite a lot of water will run down. It's going to slow it down, sink it in, spread it out. Any excess will go to the ponds and then move it through the landscape. So that is one of the guys that helped on the job. We'll call him Shaggy. And Shaggy is surveying. And this is something that you don't necessarily see naturally. So this water is now sitting on the side of a hillside on contour. So the contour is perfectly flat, and then the swale turns the corner and goes around flat. So imagine I don't walk uphill, and I don't walk downhill. I walk perfectly flat across the hill, similar to like a train goes around. Yep. So that's it. That's how that works. And there we go. Swales on contour, holding water on a hillside. Pretty much after about a month, things are looking nice. Start to see the ground covers start to take shape. Grasses are coming back from the upper part into the swale bank. Nice ground covers. And pioneer trees, those tree seeds that were originally planted in the mulch are starting to come up. Originally this will be the first, or legumes, that will create and then finally the long-term trees will come in afterwards.